Hello, science enthusiasts! Welcome to HPL Discovery. My name is Mary, and today we're going to learn a little bit about how we see color. First of all, let's start with the basics. We see it all because some of the radiation from our sun comes in wavelengths that our eyes can perceive. So, when those wavelengths come from the sun and bounce off of objects and hit our eyes, cells in our eyes send signals to our brain, which allows our brain to translate those signals into a visual image. And where color perception comes into this is that most light that we see as clear or white light actually consists of all of the colors of the rainbow. Now, how do we know this? From rainbows and also from prisms. I'm going to show you a little experiment you can do at home to divide up white light into its component colors so that you can see what I mean. We can demonstrate how white light contains all of the colors of the rainbow using a very simple homemade prism. All you'll need is a bowl of water and a mirror and a point source, such as the spotlight I have here, or a very bright flashlight, or a shaft of sunlight. Take a look at what happens when the light from the spotlight passes through the prism. This is similar to what happens when sunlight passes through rain droplets in the sky to form a rainbow. The waves of light are refracted, which is a fancy way of saying bent, and because each color is a different wavelength, they each bend at a different angle, forming the rainbow on the wall. People knew about rainbows and prisms for many years, but when Isaac Newton discovered that you could pass light through a prism to get a rainbow, and then pass it through another prism to turn it white again, he realized that all of those colors were actually part of the white light and not some separate phenomenon. So, what does all of this have to do with how we see color? Well, when you were little, you may have had a paint set, and you probably learned to mix the different colors of paint to get new colors. So, in paint and pigment, we say that the three primary colors are red, yellow, and blue. You can get other colors by mixing the primary colors together. Like, for instance, if I wanted to make green, I could make that by mixing a little bit of yellow with a little bit of blue, swirling that around, and voila, green. The way pigments work is they reflect only certain wavelengths from a white light source. So because our light here is white light, it is bouncing off of our pigments, and it is only reflecting, in this case, red wavelengths, yellow wavelengths, green wavelengths, and blue wavelengths. So, and all of those other colors are being absorbed by the pigment. So when you mix pigments together, you are absorbing more and more wavelengths. And so eventually, as you mix more and more colors together, your colors will get closer and closer to black. And speaking of black, now it's time to turn off all the lights again. Color mixing with light is slightly different from that with pigment. Our primary colors in light are red, blue, and green. When we mix red and green together, we get the secondary color of yellow. When we mix green and blue together, we get the secondary color called cyan. And when we mix blue and red together, we get the secondary color called magenta, which isn't showing up very well on my camera, but you get the general idea. When we overlap all three colors, you can see where the secondaries are formed, and at the center, you can see our light is approaching white light. Now, to explain the experiment. In your kit, we have provided the instructions, which are always the most important part. We have provided 3 different transparent color filters to put over a light source. We have provided a color mixing chart that shows how the different colors of pigment are produce the different colors, and a different color mixing sheet to show how different colors of light mix to create the colors. And we've also provided a sheet with colored rectangles. How we do the experiment is you can cut out your colored rectangles, find yourself either a darkened room, or you can put a blanket over your head, or you can do this experiment inside a large cardboard box, wherever you can limit the light that comes in. And what you're going to need is a point source, such as a flashlight, a spotlight, or even a cell phone flashlight will work. What you want to do is take your colored rectangles and cut them apart. And you want to look at them under the different colors of light to see how different they appear. All right, I'm going to turn off our lights and we're going to take a look. All right, here we are in our darkened area, and I've set my colored pieces of paper out on the table, and I am looking at them under my red light. And as you can see, I'm having a really hard time telling which one of these colors is which with only red light to look at them. But I'm going to guess that this one is the red because it looks the closest to, no, well, I'm going to guess that this one is the red. If you want to do this yourself, you can write the colors that you guess on there, or however you want to do it. All right, now I'm going to use my white flashlight to see, was I right? No, I was not right at all. There's the red right there. All right, so let's mix them up and try a different color and try it again. All right, now I'm going to look at them with blue light. Can you tell which is the blue rectangle? Well, I'm going to bet it isn't that because there's no blue wavelengths bouncing back from that. It's probably not that. It's got to be one of these two over here. All right, let me add in the red wavelength and see if that helps me figure it out. I think that one's looking more and more blue by the minute. Let's turn on the white light and see if we're right. Yep, that's the blue one. All right, let's mix them up again, and we'll try looking at them all under the green light. All right, can you tell which one of these is the green rectangle? I'm going to guess that it's that one. All right, let's add in another color. We'll add in some red light here. And where those overlap, we should be getting yellow light, which still looks pretty green. Let's add in the blue light. Yep, we're getting closer and closer to white light now. Let's turn on the flashlight with white light. And sure enough, that was our green. Have fun playing with light and color. If you would like to learn more about the visible spectrum, or about how the rods and cones of our eyes help our brain to perceive light and color, the library has many resources to help you. Visit our website or call us, and we can help you find the information that suits your interests. Color vision is a fascinating subject, and this experiment barely scratched the surface. So explore more, and I hope you have great discoveries. See you next time.